Alright, we've seen this definition in class several times now. Over here, the one I'm talking about. And again, what this gives us is the slope of the tangent line of the curve at A. So meaning if I wanted to find just a tangent line to this curve at A, that's what this gives us. Now I'm going to draw the tangent line in there. Okay, so that blue line that I just had drawn in here, this is the line that's tangent to our function. This is our function, this cubic function. It's actually x cubed minus 2x squared. That's our function. And this line, the tangent line, is tangent to the function, touches the function just at point A and doesn't touch it again. Alright, now I'm going to tell it to show the equation of that line. X plus y equals 0, or y equals negative x, if you want to call it that. Meaning that this point right here, when it touches that line, the tangent line's curve has a slope of negative 1, right? So the equation of this line is y equals negative x. Now, what I'm going to do is I'm going to show you virtually what this actually means, visually, so you can see what it means. This is our point in question. This is the point that we're wanting to come up with the equation of the tangent line. Now this software gives it to us anyway, and we want to know what the slope of that tangent line is. So what I've done basically is I'm holding this point firm. I'm not going to allow it to move. Right? It's point 1, negative 1. So our A value in this notation excuse me, is 1, because A is an x value. It's a number on the x-axis. Okay, this is f of A. F of A is negative 1. Okay, so that would be negative 1. This would be positive 1. But we've created a second point on here that I'm calling B. Right now B is just randomly 2.38, 2.15. But B, which is acting like our x, gets to move around. I'm going to be able to move B around back and forth as I want to. And notice I also have this line connecting A and B. Alright, now what this is, ignoring the limit as x goes to A for right now, what this is the average rate of change of this function over this interval from 1 to wherever we're stopping. In this case right now, 2.28. Alright, or we can also think of it as the secant line that goes between these 2 points. Now notice this function right here is this. It's right now y equals positive 1.92x minus 1.92. So right now its slope is 1.92. Okay, but this point and A are spread apart pretty far right now. So what this part says is allow x, the x coordinate of this second point, allow that to make its way towards A, which is 1 in this case. And as we make that, as we get closer and closer and closer, the slope of the secant line, which is this whole entire thing, will approach the slope of this line. So again, the slope of this line is y equals negative x, so that means the slope is negative 1. So I'm going to grab this point and I'm going to start moving it closer and closer towards the other point. And as I do that, notice this slope went from positive to now it's getting into the negatives. And again, as I get closer and closer and closer to A, the slope of this line gets closer and closer and closer to negative 1. So that's what we mean by this limit notation for the slope at a point, or the instantaneous rate of change. It means we're allowing that second point x to make its way towards the first point, to the point where they are sitting right up on top of each other. Alright, and at that point it says undefined because when x is A, we divide by 0. But you can see as we get really close, again, it's approaching that -1 value. Alright, and then again, if we did it from the other side, we can approach from either side. As I approach from the right side, or sorry, the left side, again, the values, now they're a little bit above -1, or below, technically. But as I get closer, the closer and closer and closer I get to that value, again, the closer the slope gets to -1, which is what we're after. Okay, now you got to think, the way it works is, this software gave me this line, but if that line wasn't there, this is a way for us to get the slope of that tangent line using the limit definition of the secant lines. Alright, I hope you found this video helpful.